Hello and welcome back. Let's talk about orthogonality. Now, if two vectors, v1 and v2, are orthogonal, or in other terms, have a right angle, then we can say that v1 dot producted with v2 is going to equal 0 because there's no v1 in v2. Now you might notice if you watched the basis video when we talked about the ijk basis, I dot j is 0, I dot k is 0, and k dot j is 0. So what does this mean? Well, that means that they're orthogonal. That means that there is actually a right angle between the three vectors. Suppose that's how you could draw it. It's not really a great right angle. Boom, there we go. Yeah. Anyways, let's not sidetrack too much. Let's talk about the projection vector. So let's say two vectors are not orthogonal. Let's take a v2, let's take a v1, and let's project v2 onto here. Now normally we would just take the dot product to get a magnitude of v2 that's in v1, but we want the direction of v1 as well. So I'm going to use my red here. This red vector right here is the projection of v2 on v1. Kind of the same way that we would write a logarithm maybe. And this will have a right angle with v2. Well, let's take a look at how to calculate that. The projection of v2 on v1 is equal to v2 dot producted with v1 divided by v1 dot producted with v1 times the vector v1. So here's our magnitude, here's our direction. Let's look at an example. Given v1 and v2, let's find the projection of v2 on v1. Well, this is simple. v2 dot v1 is minus 1 plus 0, so minus 1, divided by v1 dot v1, which is 1 plus 4 is 5. And our vector v1 is 1, 2. There's our projection of v2 on v1. And I believe that's it for orthogonality. In the next video, we'll talk about orthogonal and orthonormal basis. And that's when it gets a little more complicated, but it's really not that bad. So I hope to catch you in that video. Hope this video helped, and thanks for watching.